All right. So today we'll just take a look at some functions in R, or writing functions in R. And I also wanted to provide just a little bit of overall strategy as far as kind of breaking a task down into simple steps, working in the global environment and things like that, which I think will be helpful when you have to write a function, and and for your second homework assignment, it gets a bit involved, and so I wanted to just provide a little bit of guidance as far as ideas for getting started. Okay, as far as functions go, the basic idea or structure of a function is that you have the name of your function, and you're going to say, we are going to assign some function, okay, using the assignment. You're going to say, we're going to assign this function to this name, and the name is going to become whatever you have here is going to become the name of the function. And so we have argument 1 and argument 2. These are going to be the names of the variables that get sent to the function. Inside the function, you have these different lines of code, which I've written as expression 1, expression 2, et cetera, et cetera. These are going to be the lines of code that get executed. And then at the end of the function, it's going to return some kind of output. Okay, and you can take this output and then assign it to an object or whatever you need it to be. If generally you group these lines of code together using curly braces, but if there's only one line of code, curly braces are not required. And if you don't explicitly use this function return to return the object, the last expression that's calculated will be the value that gets returned. Okay, so here I've got f is going to be defined a function that takes in some argument x, and it's going to do the calculation x times x. I don't have any curly braces here, and this is the last expression that's evaluated, and so it's going to return the value x times x. Functions themselves are objects, so you can just kind of put them in other things. So here I have a list with a function inside as one of the objects. If you ask what is the type of for a function, it will say it's a closure. Or if you ask the mode of a function, it will say it is a function. You can use an explicit return, or you don't have to, and this is called an implicit return. Okay, so if you use the return, this will be the value that gets returned. If you don't use a return anywhere in your function, then the very last line that gets evaluated is going to be the value that gets returned. Okay, and for whatever reason, this is the recommended style using the implicit returns. Now, that's not to say you can't use explicit returns, and explicit returns are very useful when you want to return a function early, or return a value early. And so so when you execute a function can only return one value, and it's only going to return a value once. So you can have a whole bunch of lines of code, but then if it encounters a return statement, it's going to return a value and it's going to stop. It's not going to execute anything that comes after the return statement. So a function, as soon as it hits return, a function kind of sees its purpose in life as complete, and then it will disappear and close. Okay, so it just it runs it as soon as it encounters a return, even if there's a ton of lines of code afterwards, it's just going to return the value. It's going to be done, and the function closes. Okay. Functions are only able to return one object. So if you have multiple values that need to be returned, or you want returned, you have to combine them together into a single object. So one option is to use combine them together into a vector if they're all of the same type. So you can take x and combine it with x squared and x cubed, and you can return a single vector with 3 values in it. So here I can run f of 2 and it returns 2, 4, and 8. And that's fine. Or you can choose to use a list to kind of combine objects together. And this is more useful if you have multiple different types of values. Okay, they still get grouped together into a list. A list is very flexible and can contain all kinds of stuff. So you kind of just group everything together into a single list and you return the list. So here f is a function. There's only one line of code and it's just the object that's going to be returned. What it's going to return is a list where the name is x and the value is x. The name square is the value x squared, and the name cube is the value x cubed. All right, and so if you run f of 2, it returns a list of 3 elements. X is 2, square 4, and cube 8. When you create a function, you will also give it some arguments. Okay, these are the variables that get used inside the function, and so in the defining of the function, whenever you assign it somewhere, these are going to be the names of the arguments that get used inside the code here, right? So if you say x, y, and z here, you kind of have to use the letters x, y, and z inside your code, right? And so this is just a very silly function. It's just going to take 3 numbers, x, y, and z, or 3 values, x, y, and z, and then it's going to paste them together. And so it's going to say x is equal to whatever x is, y is equal to whatever y is, and z is equal to whatever z is. And it just kind of takes them in, okay? And so here, if I say f of 1, 2, and 3, it's going to take 1, and it's going to kind of paste it together into a single text string, okay? And it's going to end up saying x is 1, y is, and it takes this value 2, and z is this value 3, and it gives me a single string that says x is 1, y is 2, and z is 3. When you have the names of the arguments, and if you don't supply the names of the arguments here, R is going to assume that you've supplied them in order. X first, y second, z third. Okay, right here. Okay. You can explicitly specify the order, and you can say, I want z to be 1, x to be 2, and y to be 3, and R will comply. It's going to say, okay, z is 1, so that's going to throw it into the 3rd position here. And x is 2, and y is 3, and it arranges them accordingly here. If you specify the names of only kind of 1 or 2 arguments, then R is going to do its best to try to match them accordingly, right? So here I've got y is 2, and then I didn't supply what 1 and 3 are, so it's going to just say, all right, well, I think the 1 goes into the 1st position, 3 will go into the other argument that wasn't named, okay? And so now we get this. Here I've given y equal to 2. I didn't supply a name here, x is 3, and so R is going to try to figure this out, and it says, okay, well, the only argument that wasn't named was z, so we're going to put the 1 over here, okay? And here, if I give it a function, and I say, or given an argument, m equals 1, R is going to say, I don't know what to do with that, okay? M is not part of, is not one of the arguments that is in the definition of the function, and so it's going to, so it complains here, okay? You might encounter something like this if you accidentally create a function that has the same name as another function in R, all right? So there's a homework assignment, and sometimes the functions, you might name your function A, function B, function C, function D, function E, so on and so forth. And later on, you want to kind of combine some values, and you say, I want to create a vector, and I'm going to combine 2, 3, 4, and 5. Okay. And then when you try to combine 2, 3, 4, and 5, you encounter this error, unused argument. Okay. And the reason for that is because you have defined another function called function C. Okay. Function C is now kind of masks, or hasn't overridden, but when you make a call to function C, it's not trying to combine the values as we normally do when we use C to combine values together into a vector, but it's trying to use the function that you defined as function C. And that function probably doesn't take on a bunch of arguments, and so it gets confused when you try to combine values together. So stuff like that happens. Argument values are required. So if you don't supply a value to an argument, R is going to error out. Okay, so actually, maybe I should show you this. Here, I have a function that takes on the values x, y, z, and w, and it pastes x, y, and z together. And here, as far as the function goes, I gave it a value for x, a value for y, and a value for w, but I didn't give it a value for z. And so as far as creating this expression goes, it says z, there's no value for z. Argument z is missing. And so it gives me an error here because it doesn't know what to do. Okay. Let me go back to this slide. Here, the function takes on arguments x, y, z, and w. W is provided the value 4. It's not used anywhere here, but R doesn't care. It just takes on and prints out x is 1, y is 2, and z is 3. Okay. And here I didn't actually supply a value for w, but it still runs because it doesn't actually need w anywhere inside the expression that gets evaluated. Okay, so w is not needed as far as evaluating the expression, so it doesn't matter, it still runs. Okay, but over here z is needed, and a value for z is not provided, and so it complains or errors out. So if you want to avoid this kind of situation, you can provide default values. You can say, you know what, if I don't provide values for an argument, like in this case, I didn't provide a value for z, you know what, just go ahead and use this value, use the value 1, okay? And so here I'm gonna, inside the definition of the function, up here, I say if x is not provided, use the default value 1. If y is not provided, use the default value 1. Or if z is not provided, use the default value 1. And so here I can just say, all right, we'll call f with no arguments. And so it's going to just use all default values, and it says x1, y1, z1. Okay. Here I just say f of 2, and 2 is going to get plugged in for the first argument, and it's going to use defaults for the other values. Okay. Or I can say f of z equal to 3, and so 3 gets plugged in for z, and it uses defaults for the others. All right. All right, so far so good? Great. Okay, thank you for that thumbs up. Let me go ahead and give you your first quiz answer for today's lecture viewing quiz. Your first quiz answer is D. D as in dog. D as in dog is your first view quiz answer for today. D as in dog. So one thing that's important is to know that values that are created inside a function exist only inside the function, okay? You cannot really get values out of the function. Values inside the function do not affect things in the global environment, with the exception of the super assignment operator, which we'll get to later, like on Friday. But in general, you only get values into the function by using the arguments. And if you want to get values out of a function, it needs to be part of the object being returned. So either it's the value that gets returned, or it's put into a vector or a list that gets returned. Okay. Otherwise, values inside the function don't affect the global environment. So here's an example. I'm going to assign the value 10 to x in the global environment. And here I create a function f. Okay. And inside the function f, I'm going to take the value x, add 55 to it, and store it back to x. Okay. And at the end of the function, we return the value x. So when I execute f of x, I take the value 10 is assigned to x. So it's running f of 10. 10, we then execute this function here. 10 comes in as x. We do 10 plus 55. That becomes 65. 65 gets assigned to x. And we return the last line. This is going to be the value that gets returned, and it returns 65. X is 65. Okay. However, this assignment operator assigns the value of 10 plus 55 or 65 to the x that exists inside the function. This x inside the function has nothing to do with the x that's outside of the function. Okay, so the value of x in the global environment, when we ask what is x in the global environment, that's unchanged and remains 10. Okay, even though we've assigned 65 to x inside the function, this exists only inside the function, and as soon as the function is done running, everything inside that function environment just kind of poof disappears and it's gone. So if you want to store this value 65, you have to assign it, okay? So here x is 10 in the global environment. I can run f of x and I get 65, but again, x remains unchanged. The only way I can change it is by doing f of x assigned to x, and then when I do that, f of x is 65, and that's going to get x is now 65, okay? And that's because I've done this assignment right here. I want you guys to start getting into the habit of thinking about functions and possibly writing a function when it's time to write one, okay? And so the guideline is, well, whenever you're working on a coding project, it is a common idea where you say, okay, I got this thing working here, and I need to do something similar down here. And so you just kind of take your code, you copy it, you paste it down here, and then you change a few variables or a few values, and then you run it again. That's a very common experience as far as writing code, because you say, well, this got working, and I need to do something similar down here, okay? So if you copy and paste it once, that's fine, okay? The code now, similar code exists in 2 locations. If you copy and paste it twice, you know, you should probably start thinking about a function, but maybe it's okay. The same code exists in 3 locations, right? You have the original, you've copied it and pasted, and you copied and pasted again. So the same code exists in 3 locations. Okay, by the time you're about to copy and paste the same code into a 4th location, that's the point where I say it should be a function, okay? You should turn it into a function by that time, just because at that point, the same chunk of code kind of exists in 4 locations. And later on, let's say you realize, you know what, I need to make a small change here. Then you've got to kind of hunt out, you know, the same chunk of code in 4 locations, and you have to make sure you make the same changes in all 4 locations. And that's going to be kind of a pain to do. So when you, so if you're going to catch yourself copying and pasting it a 3rd time, at that point, you should say, you know what, I need to be writing a function by now, okay? And that way, if you need to make a change in the future, you just change it in 1 location and it's going to update in all kinds of things. You don't want the same chunk of code existing in 4 locations. I would say 3 is kind of the upper limit of pushing it. Copying and pasting it 2 times, it's kind of the upper limit before you ought to write a function. Okay, and so overall, yeah, better to change the code in 1 location than try to change copies of the code everywhere. When you name your function, the name of the function should at least indicate what the function is going to do, okay? In all of my examples, I have terrible names. I've used like the function name is f or the function name is f2 or something like that. Those are bad names, okay? Single letter names for functions in general, bad names for functions, okay? If your function is going to return a true or false value, then a good idea is to start the name of the function with is, okay? Because that kind of implies that it's going to return a logical value, like is it character, is it prime, type of thing, okay? And then what a function does, you want it to kind of be simple enough to be understood quickly, okay? So I want to spend a little bit of time just working through an example of how you might approach writing a function, okay? How you might approach writing a function. And, you know, some of you guys, maybe you have a lot of experience writing your own functions and do a good job. And others of you, maybe this is kind of a newer thing. And so, so I wanted to just provide a little bit of guidance here, okay? So what we're going to try to do is we're going to write a function to perform bubble sort. So let me at least explain what bubble sort is. Bubble sort is an algorithm that will sort a vector, basically, right? You give it a bunch of numbers and it will sort it from least to greatest. And this is not in common use today. It's not the most efficient algorithm, but it was popular in the early days of computing because it required very little memory usage, right? So today, you know, memory is hardly a problem. You have like 8 gigabytes, 16 gigabytes of RAM on your computer. But, you know, back in the day, you might have like 16 kilobytes or 8 kilobytes of memory on your entire machine. And, you know, each number, you know, took up like 8 bytes of memory and things like that. And so, so you really wanted to limit how much memory you were using for your program. And so bubble sort was popular, okay? What bubble sort does is it's going to just compare two numbers, the quote bubble, and if the two numbers are in order, it leaves it. But if the two numbers are not in order, meaning the left number is smaller or is bigger than the right number, it's going to swap them. So they end up in order, okay? And it goes through and it's going to swap, and then it's going to move down to the next operation and swap if they're out of order. It's going to leave it if they're in order, and it's going to kind of perform multiple sweeps. Okay, so here's an example. Let's say you have this vector 5, 1, 8, 2, 4, and what it's going to do is it's going to start by comparing the first two values, 5 and 1, and it's going to say, okay, are these two numbers in order? They are not. Okay, because 5 is bigger than 1. So it's going to swap those two positions, and we're going to get 1, 5. Okay, 1, 5, 8, 2, 4. Then it moves to the next two values. It's going to look at the 5, 8, and it's going to say, are those two numbers in order? And yes, they are. 5 is less than 8, so it's not going to swap them. It just leaves them. Okay, then it goes to the next two values, and it looks at the 8 and the 2, and it says, are these two in order? They are not in order. Okay, 8 is bigger than 2. So it's going to swap these two numbers in the bubble. Okay. And then it looks at the last two, 8 and 4, and it says, are those numbers in order? They are not. And so it swaps them, and it's going to put the 8 in the last position. Okay. And when you kind of work through this, what's going to happen is if you follow this, then at the end of kind of going through the entire vector, we know for sure that the very last number is going to be the largest element. The largest element will get pushed all the way to the right if you kind of perform this swapping, okay? One sweep of it, okay? And so in order to sort the rest of the vector, we just kind of run through the same thing again, okay? We know that 8 is in the correct position, so we can, quote, lock it in place, and we're going to just perform a second pass. So that at the second pass, we're going to look at the 1 and the 5. We're going to say, do we need to swap? We do not need to swap. Okay. We go to the next two. We look at the 5 and the 2, and we say, do we need to swap? We do. So we swap them. Okay. And then we look at the next two numbers, 5 and the 4, and we say, do we need to swap them? And we do. They are not in order. So we swap them, and we get 4 and 5. And there's no need to swap these two because, or even check these two, because we know the 8 is in the correct spot. Okay, we know the largest number is in the correct spot. So at the second run, we only have to do 3 comparisons. Okay, so the first run we ran 4 comparisons. Here we run 3 comparisons. Okay, and now we know the 5 is in the correct spot. Okay, and at this point, the algorithm or the vector is in the correct order, but the algorithm doesn't know that. So it's going to just kind of compare this again. It's going to look at the 1 and the 2, and it's going to say, okay, those are in order. It's going to look at the 2 and the 4, and it's going to say, okay, those are in order. And now we know that the 4, 5, and 8 are in the correct position. Okay, and then finally it looks at the 1 and the 2, and it says, are those in the correct order? And they are. So it doesn't perform a swap. And so now we know all of the values are in the correct order, 1, 2, 4, 5, and 8. All right, is that okay as far as how the bubble sort kind of algorithm works here? Okay, and so there's actually an animated little thing of it on Wikipedia. This is, let's see if I can. Okay, so it starts off, it's a little painful to watch the whole thing. But it starts off and it's going to compare these two numbers, okay? And says, okay, are 6 and 3 in the correct order? They are not. So it's going to swap them. Okay, and it moves to the next. And it's going to say are 6 and 1 in the correct order? They are not, so it's going to swap these two. And then it looks at the 6 and the 8. It says, are they in the correct order? They are. So it moves on. What about the 8 and the 7? They are not in the correct order. So it's going to swap them. And then it goes to the 8 and the 2. They are not in the correct order. It's going to swap them. And then the 8 and the 4. They're not in the correct order. So it's going to swap them. And when it does that, we know that the 8, the very last number, is in the correct position. So this gets locked down. Okay, we compare the 5 and the 3. We swap them. We compare the 5 and the 1. We will swap them. And then we compare the 5 and the 6. Those are in the correct order. So we leave them and we move to the next pair. 6 and the 7 are in the correct order. So we leave them. The 7 and the 2 are not in the correct order. And so we swap them. And then the 7 and the 4 are not in the correct order. So we're going to swap them. Okay. And then at that point, the 7 is in the correct position. So that gets locked in. And this just kind of keeps repeating until all of the numbers are in the correct order here. Okay. All right. So what we want to do now is we want to try to code this up, and we want to try to make sure we want to see if we can write code to execute this. Okay. Actually, before I get into that, let me give you your second quiz answer for today. Second quiz answer is C. C as in cat. C as in cat is your second quiz answer. And we will we'll take a look at kind of writing this, okay? And so anytime you have a big kind of task that you want to do, just break it down. Break it down into real small tasks, simple tasks, and see if we can kind of code those things up, right? And this is kind of the strategy here. So we're going to say, all right, the bubble sort algorithm can be kind of broken into smaller tasks. One is compare 2 adjacent values, swap them if they're not in the order. And that's going to be just comparing 2 adjacent values and then swapping 2 adjacent values. And then we're going to have to perform multiple sweeps on the vector. But every time we perform a sweep, we have to just do 1 fewer comparison, right? The first time we had 5 numbers and we did 4 kind of comparisons. The next time we did 3, the next time we did 2, and the next time we did 1, right? Every time we kind of perform a sweep, a value gets locked in, and you only have to do comparisons for the positions that are not locked. Okay. So my advice, don't start writing a function, okay? See if you can just swap 2 values in a vector, right? So I've got x is 5, 4, 3, 2, 1. And if I swap, let's say we just swap these first 2 values, the 5 and the 4, what should the result be? It should be 4, 5, 3, 2, 1, okay? So can I write a piece of code that is going to swap these 2 values? So let's just start there. Let's just start real simple and just say, can I write a piece of code that's going to go from 5, 4, 3, 2, 1 to 4, 5, 3, 2, 1? Can we successfully just swap the first 2 numbers? Okay. All right. So what I'm going to do is I'm going to do this in our studio and actually clear all of this out. This is from the last class. Are you guys still able to kind of read what I've got on my screen here? I'm hoping everything is not too tiny. Okay. And so what we want to do is we want to write some code, right? So, you might be tempted. Let's just like write a function. Okay. Let's call this swap the first 2. And it's going to be a function of some vector x. And what we're going to do is we're going to say, all right, let's into x position 1, let's take the second value, and let's take into the second position of x, let's plug in the first value, and let's return x. Okay, so we'll run that. We'll say x is 5, 4, 3, 2, 1. Okay, and then let's try swap the first 2 on x. And if I run that, I don't get what I want. Okay, so x is 5, 4, 3, 2, 1, and what I want is 4, 5, 3, 2, 1. 4, 5, 3, 2, 1. This is not the result I want. I got 4, 4, 3, 2, 1. Okay, I want to swap the first 2 values. I want 4, 5, 3, 2, 1. Okay, And okay, well, what went wrong? Okay, it's hard to know. It's hard to know what happened inside the function. Okay, and so this is why I say don't try to do things in a function immediately. Okay, just work in the global environment. And when you work in the global environment, you're able to see the values of the functions. Okay, and with RStudio, you're able to see the values that exist in the environment real easily. Okay, so I recommend always just kind of clearing out the global environment. So I put in this first line, remove list equals ls, and this will always kind of just delete everything that exists in the global environment. Okay, and we're going to just start off with by saying, okay, let's create the value, the vector x. X is 54321 right here in the global environment. I mean, I can print out x to just see, but there's no need. You can kind of, this is one of the nice features of RStudio is you can kind of get a glimpse of what it is. All right, and let's see what happens if I want to kind of swap the first two values. Let's just kind of write the code I had for swapping the first two values. I got x, x2 goes to x1, and x1 goes to x2. Okay, so we're going to just kind of run this first line of code. Okay, and we can say, okay, when I run x2 goes to x1, we can see what happens to our vector. We can say, oh yeah, x used to be 54321. But we've taken the second value and put it into the first value, and we can see we get 44321. And so when I run the next line of code, I'm taking the 4 and I'm putting it over here, and it doesn't achieve it, right? We can see when I copied the 4 in over the 5, it basically deleted that 5 value. That 5 is no longer in existence. Okay, so is that okay that we're just kind of looking here? So x starts off 54321. Okay. And when I do copy the second position value into the first position, and we look at x, we can see it's now 44321. Okay. And so, you know, even if I try copying the first position and second, you know, it's no good. So what I need to do is I need to take the second value, or take that first value, that 5, and store it into kind of a temporary location. Okay. So we're going to start off. We're going to, again, wipe everything out. X is 54321. I'm going to take that first value, 5, and x position 1, and store it into this temporary location. Okay, and so temp takes on the value 5. And now I can copy the second value, the 4, into the first position. And what I want to do now is into the second position, I'm going to put that temporary value. Okay. And we can see, okay, that is what I want. Now I have 45321. Okay, and I can check, and I have x, and indeed I have 45321. And so this is just kind of one way we can achieve the swapping of the values. Okay, and we can say, all right, let's just try something else, right? What if I have the values 1 through 8? Okay, we're going to just kind of, if I swap the first two values, then we'll go 2, 1. And indeed, this works. Okay. All right, so that achieves the goal of just kind of swapping two values. Okay. But what we want to do is we don't want to swap the values if they're already in order, right? So can we just kind of look at the first two values, and we'll only swap them if they're out of order. So we're going to add a condition. I'm going to take this, I'm going to indent my code, and I'm going to create an if statement. And we're only going to do the swap if the first value is greater than the second value. That's when I will do the condition. So then I put curly braces. Okay. So I start by kind of wiping everything out. We're going to create x's 1 through 8. And here we should not swap the values because these are already in order. So I'll just check. I'll do, I run the line of code. I check for x at the end. And indeed, it didn't swap. Okay. Let's try another example. We're going to clear everything out. X is 8 through 1. And this time, when I run it, I'll just look at the first two values, 8 and 7. Those are not in the correct order, so we do want to swap. So when I run the code, indeed, it did run, and the first two values did get swapped. All right, is that okay? Okay, so here I swapped the first two values, okay? And what I want to do is I want to not just swap the first two values, but I want to go to the second and third. I want to go to the third and fourth, and I want to kind of go through the entire vector. So what I'm going to do is I'm going to take this code and I'm going to put it inside a loop, okay? And rather than just saying look at position 1, position 2, inside the loop, we're going to use kind of like for I in 1 through the length of the vector, basically. And I'm going to replace the 1s with an I and the 2s with an I plus 1. Is that okay? So here I'm going to replace the 1 with an I. The 2 becomes an I plus 1. Okay. And the 1s get replaced with an I. And the 2 will get replaced with the I plus 1. I plus 1. Okay. And we can just kind of just test this out. And we can say, all right, if I is 1, there's that. And we'll run it. And indeed, it works fine. 7, 8, 6, 5, 4, 3, 2. And then we can say, all right, let's just try this again with I equal to 2. And we run it. And indeed, it seems to be working. Okay. The 8 has now moved 2 positions over and so on and so forth. Okay. So with that, we can kind of just, I'm going to get rid of this I2 business. Okay. And I'm going to just kind of indent my chunk of code, and I'm going to put it inside a for loop. Okay. I'm going to say for I in, I'm going to do a sequence length, and the length is going to be the length of X. Okay. And the sequence length will just go 1 through 8, or however long X is. Okay. All right. I guess we'll do 5, 4, 3, 2, 1. Okay. So let me go ahead and just clear everything out. X is 5, 4, 3, 2, 1. And I have this loop that's going to start off for I in sequence length of 5. So that's going to go 1, 2, 3, 4, 5. And we're going to run this. Okay. So when I run this, I can check on X, and it looks like it kind of worked. It goes 4, 3, 2, 1, and 5 got pushed all the way to the end. Remember, we started off 5, 4, 3, 2, 1, and 5 got pushed all the way to the end. But I also got an error. It says error in if x of I greater than xi plus 1, missing value where true false needed. Okay, I got a missing value where true false needed. So we see a missing value where true false needed if we have basically an NA somewhere in my if statement. Okay, so let's just go ahead and take a look. All right, I is the value of 5. Okay, and so I can say, all right, well, what is x of I? X of I is 5. What is x of I plus 1? Because what we want to know is we want to know what's inside my if statement that's not working. Okay, x of I plus 1 is NA. All right, and that actually makes sense because I here is 5. I plus 1 is 6. And there's no 6th value in my vector of length 5. Okay, so because the 6th value doesn't exist, we have an NA, and so we can't do the comparison. Okay, so as far as my loop goes, the problem is I'm going all the way to the end. When I have a vector of length 5, I only need to actually do 4 comparisons. I don't need to do 5 comparisons. So my sequence length should not be length of X, but my sequence length should be length of X minus 1. Is that okay? All right, and so we can just kind of run this code again, and we'll start off with X being 5, 4, 3, 2, 1, and then we will run this. And I didn't encounter an error. And if I check on X, now it goes 4, 3, 2, 1, but the 5 is in the correct position. 5 is has been pushed all the way to the end. All right, so that looks good. Okay, so this is, sorry, let me just keep, all of this has been explained in the code here, or in my slides here, where I encountered the same issue, missing value where true false needed. And we see that the values are missing and so on and so forth. So we're going to just change it to sequence length of X minus 1. Okay, we're still working in the global environment. So here we can just kind of test a few more cases. All right, I can just see, all right, let's just try this case. So anytime you get your code working, just try a few more test cases, right? You're still kind of in the global environment. Yeah, indeed, when I ran it, it pushes the largest value all the way to the end. Okay, we just kind of want to make sure that no matter what we have here, okay, so here I can do sample size 10, okay. X is kind of out of order. We want to see if we run this, is it going to push 10 all the way to the end? It does, okay. So indeed, that's what we want to see, all right. Okay, so this looks good. And what we want to do is we want to sort the entire thing, not just push the largest value all the way to the end, but we want to kind of run it multiple times. We're going to run multiple sweeps so that the entire vector gets sorted, okay? And so one simple thing I can do is I can just say, well, let's just run the code one more time, right? So here's my chunk of code, right? We'll run that. After one run, 5 is pushed all the way to the end. If I just copy this chunk of code again and I run it, then 5 and 4 have both been pushed to the end, okay? And I can just run this multiple times. And so I can take this entire piece of code, I can indent it, and I can put it inside another loop, okay? I can do for, just say s in, and we'll do sequence length. I'll just do length of x minus 1 again, okay? And I can just say, well, you know what, let's just go ahead and run this, length of x minus 1 times, okay? So here x is 5, 4, 3, 2, 1, and I can run this. And indeed, it looks like it's sorted. 1, 2, 3, 4, 5, okay? Let's just try sampling 100 numbers, okay? And I can run this. And indeed, it looks like X is sorting. Now, there's some inefficiency going on, right? And that's because I haven't taken advantage of the fact that every time I perform a sweep, one of these positions gets locked in, and I don't have to do the sweep on the full vector. I can just kind of shorten how big the sweep is. Okay, so what I can do is I can kind of keep track of kind of how many values are in locked position. Okay, and so in the beginning we're going to say, all right, the number of positions that are locked is 0, and every time I perform a sweep, okay, which is after, so this is basically the inner loop performs a sweep. And this is sweep multiple times. Basically, every time I perform a sweep, I can lock in one more values. So the number of positions that are locked is going to increase. And what it's going to affect is how far down, how far the sequence length do I have to check. I can check the length of my sequence that I need to check can decrease by how many values are locked in each spot here. Okay. Does that kind of make sense? So every time I perform a sweep, one more position gets locked. Okay. So I'm going to add 1 to locked, and how many, then how long does my sweep have to be? It's going to decrease by how many values are in locked position. Okay. And so we can kind of clear everything out. We can create a vector of length 100, and this is all out of order here, and we can try running our code. Oh, it says locked. Oh, sorry. We're going to start off with locked as 0, and then we're going to run that. And indeed, it looks like it's sorting. Okay, we end up getting the values 1 through 100. Okay, and we can just kind of just try some other sorted mixed up values here, and then we perform our loop, and X is now sorted. Okay, so this entire time I've been working in the global environment, and that kind of gives me some insight as to what's happening. Okay. Now that we've done that, we can consider putting all of this code into a function. Okay, so I'm going to create a function called bubble sort, and this will be a function of some vector x. Okay, and then we'll run that. Okay, so let's just go ahead and try that. we'll create a sample here. We'll do bubble sort of that, and then we'll just try bubble sort X, okay? And when I do bubble sort X, it doesn't look like anything's happening, okay? And again, when we look at the definition of the function, oh, we realize, you know what, there's no value being returned, okay? So what we want to do is we want to sort X and we want to return X. So we're going to put X as kind of our last line of code inside here. So we'll just do that. We define bubble sort. Okay, so X is this vector that's not in order. We'll run bubble sort of X, and it gets put in order, okay? And so we can define X being, just shuffle the values 1 through 100, and we can try bubble sort on X, and it looks like it's working, okay? So this is, so this looks good, okay? And so that's just kind of a little bit of strategy here as far as coding up some kind of function is to kind of break it down into smaller tasks. And again, I recommend that you work in the global environment before you try to wrap everything up into a function, okay? Just get everything working. Once you get it working, then you can indent your code and put it inside of a function, okay? For your second homework assignment, one of the things you're going to need to do is you're going to have to create a game board, okay? So let me just kind of skip through this, and it can feel a little overwhelming trying to create this game board for chutes and ladders, and so so I've just given you a little bit of ideas to get started, okay? First off, I recommend working in the global environment, creating a blank new plot, and then see if you can start adding the elements of the game board, like adding a segment, adding text, and things like that, okay? And so the first thing is, our board is a 10 by 10 board, and so, what happens if you draw a segment? Okay, so here I drew a segment from X and Y being 0, 0, and the endpoint being 10, 10, and I just get a diagonal line. So that's actually not what I want, okay? Let's say I want to draw a horizontal line. That's going to be at XY 0, 0, and this coordinate over here is going to be 10, 0, okay? So here X1 is 10 and Y1 is 0, and that draws a horizontal line, okay? All right, what if, and so let's say I want to add a second line. Adding a second line, I'm going to do from 0, 0, from 0, 1 to 10, 1, okay? And so that puts a second line right here. Okay, what if I want to add a third line, okay? And so when I try to add a third line, nothing appears, okay? And so this is an indication, all right, I got to figure something else out, okay? Notice right now, I'm not writing a function. I'm just writing commands straight in the global environment. And every time I'm kind of just clearing everything out and I'm plotting something, creating a new plot, okay? I'm just working straight in the global environment. I just want to see, can I just create some grid lines, okay? So at this point, I've got 0, 0, going from 0, 0 to 10, 0, 0, 1 to 10, 1, and I've got 0, 2 to 10, 2, and this third line doesn't appear. So that tells me, you know what? I need to adjust kind of the limits of my window, okay? So I use this function plot window. I add my X limits and my Y limits from 0, 10 to 0, 10. My aspect ratio is 1. That's going to keep things square. And now I have 3 segments and I got 3 lines here, okay? And so what I want is I want to have 10 rows. So I'm going to have a total of line segments starting at 0, 1, 2, 3, all the way up to 10. Okay, so I'm going to wrap this into a loop. I'm going to take my segments, I'm going to put it into a loop, and I'm going to say for R in 0 through 10, and we're going to start off at row 0 going up to row 10. Okay, and so now I have 11 lines and basically 10 rows in between. And then I kind of follow the same logic to do the vertical segments for the columns. And I'm going to draw from, C0, and I got the vertical segments here. Okay. And this just is a very, very rough starting point. And notice I'm still working in the global environment. I'm kind of clearing my global environment here. I'm not wrapping things up in a function. Okay. If you try to wrap things up in a function prematurely, it's going to become a frustrating experience because you can't really see what's happening when something breaks. Okay, in the global environment, you can kind of identify these things. And so once you figure this out, you can then move on to the next section, which is like add text to the things, add the space numbers and things like that. Okay, add the arrows and the chutes and the ladders and all of that. And any code that I put in my slides, you are free to use. So, you don't have to follow things exactly the way I have, but I think this kind of provides like a good starting point to think about. And then you can start thinking about writing a function. Okay. One thing is that, you'll want to keep things flexible. So you want to be able to accommodate different numbers of rows, different numbers of columns. And right now it's a tiny bit confusing because I've got 10 rows and 10 columns. So while you're writing your code, it could be more useful to have 9 rows and 10 columns or something like that. And then later when you're ready to make a function, you replace all 9s with the variable name row and all 10s with the variable name columns. And that way, because right now with everything being a 10, it's a little bit hard to distinguish which one's what. Okay, so that's an idea. Okay, let me give you your last quiz answer, and then we'll call it an evening here. Okay, last quiz answer is the letter E. E as in elephant. E as in elephant is your last quiz answer. Okay, that's it for this evening. So we'll see you on Friday, and have a good night, and we'll see you then.